Hello and welcome to my channel. I am Mensah, Augustine. Please, if you are new here, kindly subscribe to my channel. And if you have been watching my videos and if you're not yet subscribed, please kindly subscribe for us to build the mathematics community. In this lesson, we're looking at complex numbers. And under the complex numbers, we are going to look at trigonometric application of the Moivre's theorem. So this lesson is very amazing. It was requested by Harriet Araba Esau of our University of Ghana, Cape Coast, and some of our other colleagues, that is Peace Adenya, Ali Muhammad, Ayopak, Richard, and then one Ebenezer Boham, and then Helen, attempt Helen to says, please, will you please give me a video on this? So I have to do this video for you. Now, let's look at these things. Very important. We will use the binomial theorem too. So you should be very careful with this lesson. This lesson, you have to watch it to the end. Now, let's move on. From the Moivre's theorem, you can write, if we let z equal to cosine theta plus I sine theta, and then we take 1 on z, which is equal to z to the power negative 1, we are going to get cosine of negative theta plus I times sine of negative theta. Wow. Now here, cosine is an even function. So cosine of negative theta will give us the same cosine of positive theta. And there is an odd function. So sine of negative theta is the same as negative sine of positive theta as 1 on z. Now, we can define a very nice formula here. Let's find z plus 1 on z. That is z cosine theta plus cosine theta will give us 2 cosine of theta. I sine of theta plus minus I sine of theta will be 0. If we take z minus 1 on z, cosine theta minus cosine theta will give us 0. I sine of theta minus I sine of theta will give us 2I sine of theta. Please take note of this. Very simple. We are going to use it here. Now, if I take z to the power n, from the Moivre's theorem, we are going to get cosine of n theta plus I sine of n theta. And if I take 1 divided by z to the power n, I'm going to get z to the power negative n, which is the same as cosine of minus n theta plus I of sine of minus n theta. And this will give us the same cosine of n theta, I've explained this, minus I sine of positive n theta as 1 over z to the power n. Now, if I add z to the power n plus 1 over z to the power n, what do I get? I'm going to get 2 cosine of n times theta. This plus this will give us 0. And if I take z to the power n minus 1 divided by z to the power n, this minus this will give us 0. I sine of n times theta minus this will give us positive 2I sine of n times theta. Now, these expressions will help us. Very simple. Ooh, I didn't take my duster. Okay, I have it here. So we have to keep these expressions in mind. I'm going to clean it because we are going to use the board. So I'm cleaning it for us to use the board. So let's write them here. z plus 1 on z equals 2 times cosine of theta, z minus 1 on z equals 2 times I sine of theta, z to the power n plus 1 on z to the power n is equal to 2 times cosine of n times theta, and z to the power n minus 1 on z to the power n is equal to 2i sine of n times theta. Okay, so let's clean this part. They are gone. We will use the binomial theorem. You use the binomial theorem. So if you can't record the binomial theorem, how would you do that? Let me take it to you very simple before. If you want to require the Pascal triangle, right? Just write 1. 1 plus nothing. Just write 1 and then repeat the 1. This 1 plus nothing will give you 1. So we are generating the Pascal coefficients. Then repeat this 1. 1 plus 1 is 2. 1 plus nothing will give us 1. Right? Then repeat the 1. 1 plus 2 is 3. 2 plus 1 is 3. 1 plus nothing is 1. So this is how we generate the Pascal coefficients. Because here we are going to use it to do our expansion. We are going to take cosine cube of theta, you expand. You are going to take cosine to the power 6 of theta, you are going to expand this. So that is why you should be familiar with this. In case exams you want to remember the Pascal coefficients, that's what we use. Here you repeat 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1 plus nothing is 1. Now, let's go to the main business. The main business is, I have the questions here. Let's look at that. Okay. We are to express the following. We have to prove the following. So first one, I'm going to take cosine squared of theta from the Moivre theorem. What expression are we going to get? Do you have it in mind? Now let's do that one. How do we do this one? To do this one, it is something, but I have to do it, right? We are going to take what we have here. So let's take 2 times cosine of theta is equal to z plus 1 divided by z, right? And that's, if I square this, I have to square this. And I'll have 4 cosine squared of theta equal to z plus 1 divided by z all squared. And this will be cosine squared of theta equal to 1/4 of z squared plus 2 times z times 1 on z plus 1 on z squared. Oh, you should learn how to expand this one. That is, you can use the Pascal coefficient. That is what we have here. So this one, we take z squared, then 2 times, you reduce the power z, then this one will come, plus this one will take the square. So we learn how to expand that one. Equal to 1/4 times, you see that we have this expression, z to the power n plus 1 over z to the power n. So we take z to the power 2, 1 over z to the power 2. So z to the power 2 plus 1 over z to the power 2. Plus this one. This is z times 1 over z. So it will cancel out and we are going to have 2. So we are good to go. This is the same as 1/4 z squared plus 1 over z squared. It's simply given by this, where n is the 2 that we have here. So we are going to put in 2 cosine 2 theta plus 2. And we are done. we can expand by multiplying through by the 4, and we are going to get cosine of 2 theta plus 1. Yes. This one is divided by 2, and this one too is divided by 2. So this will simply be half of cosine of 2 theta plus 1. Very, very simple as that. 2 goes itself 1, to go here 2, and the same thing. We are done. Now let's take another one. What about if we are to take sine squared theta? For sine squared theta, you look at the one containing the sine. So that one is given by 2i sine of theta is equal to z minus 1 on z, and if we square this one, we have to square this. Wow. So this will give us 4 sine of theta equal to z squared minus 2 times z times 1 divided by z plus, here we have negative here. So let's see how we do the negative. 1 out of z squared. Now, remember that we have I here, and I to the power 2 is negative 1, because this is the same as square root of negative 1 squared. So here you attach negative to this. So our sine squared of theta will now be negative 1 divided by 4 times, you have z squared plus 1 over z squared minus 2. Or here z will cancel the z. And we are good to go. Minus 1 on 4, z squared plus 1 on z squared is the expression that we have here. It will give us 2 times cosine of theta times n. So that is 2 theta minus 2. And the same thing like this, but here will be negative. So we are going to have, sorry, there's negative here. So I have negative cosine of 2 theta divided by 2 plus 1 on 2. That will give us 1 on 2 into brackets 1 minus cosine of 2 theta. Very, very simple as that. Now let's take more difficult questions. Let me take this thing and count. Okay, so let's take the other ones. There's negative here. Okay. So how do we do for sine cube theta? So for sine cube theta, you will still take this one. So you take 2i sine theta equal to z minus 1 on z. You keep this one and you keep this one. So this one will give us 8. And what is I cube? I cube is what? I cube is negative I. Why? Look at this. I cube is equal to I squared dot I. And I squared is negative 1 times I. And that will give us negative I. Very simple as that. So here, we are going to have 8. Or I used to do I cube. Okay. We are going to have 8 minus 8. Or we have to do cosine cube rather. Let him see. Okay, let's do the cosine cube. Yes. Let's do the cosine cube. That does not involve the I. Let's do the cosine cube. So here the cosine cube of theta, you use this one. Yes. Those that will bring the I, you forget about those ones and then you concentrate on this. So you try those ones yourself. Okay. You take z plus 1 on z equal to 2 cosine of theta. Then you keep this and you keep this. So here you are going to get 8 cosine cube of theta equal to z plus 1 on z to the power 3. And our cosine cube of theta will be equal to 1 divided by 8 times, you see the Pascal triangle, we just use it. We are going to have 1 times z cube plus 3 times z squared times 1 on z plus 3 times z dot 1 on z squared plus 1 on z cube. Make use of the Pascal triangle. And this will give us 1 divided by 8 into brackets z cube plus z will go into z squared z. So we have 3z plus 3 on z, z will go here z, plus 1 on z cube. And this will give us 1 on 8 into bracket z to the power 3 plus 1 on z to the power 3 plus 3 into bracket z plus 1 on z. Wow. Very, very simple as that, right? Now, you go here. Z to the power n plus 1 on z to the power n will give us this. So here our n is 3. So we take 1 divided by 8 into brackets. 2 times cosine of 3 theta plus 3 times z plus 1 on z is 2 times cosine of theta. And here it will give us 6. 2 times 3 will give us 6. Or let's still move forward. You have 1 on 8 into bracket 2 times cosine of 3 theta plus 6 cosine of theta. Wow. Now this will give us, if you have to multiply 2 by, okay, let's factorize 2 out rather. 2 times 1 on 8 into bracket cosine of 3 theta plus 3 cosine of theta. And this will give us 1 on 4 into bracket cosine of 3 theta plus 3 times cosine of theta. This one I've solved it, so let me cross check if the answer is correct. Okay, here we have it, it's here. But I didn't simplify it. Wow. Now let's move on. I hope you are enjoying the lesson, right? Yes. Let's subscribe and then share. Now, what about if we take this one? We are going to look at cosine to the power 4 and sine to the power 4. So if we take sine to the power 4 of theta, you take this one. That is 2i sine theta equal to z minus 1 on z. You put this to the power 4, put this to the power 4. And what is I to the power 4? I think it is positive 1. So that one will be 16 times sine to the power 4 of theta equal to, here you make use of the Pascal triangle. You have 1 times z to the power 4 plus 4 times z times negative 1 out of z plus 6 times z squared negative 1 out of z squared plus 4 times z negative 1 out of z cube, then plus negative 1 out of z all to the power 4. So we should take note of that. We have z to the power 4 plus, positive negative will give us negative. This will go here, z squared, so we have minus 4z squared. Then here, negative 1 out of z squared will give us positive 1 out of z squared. So here, the square will cancel, so we are going to have positive 6. And here we have negative 1 out of z cube. So it will give us negative 1 out of z cube. And this will cancel one of the z, and it will be minus 4 on z squared. And this one gives us positive 1 on z to the power 4. Wow, very, very simple as that. So make use of the Pascal triangle. Now let me cross check and see if we are right. Take z to the power 4, z cube times negative z. This will go here, we have that one, that is correct. This will give us positive 1 on z squared. Positive 1 on z squared. So z squared will cancel z squared and it will be left with 6. And this one gives us negative 1 on z cube. One of the z will cancel one of the z, and we have minus 4 on z squared. And we are going to have this right. So here you have 16 sine to the power 4 of theta equal to this. So we have sine to the power 4 of theta equal to 1 on 16 times. Now you can take this one, z to the power 4 plus 1 on z to the power 4 minus 4 into z squared plus 1 on z squared. Look at this one, minus 4. So factorize the minus 4 out, plus 6. So I think we can put in these values. So this one will give us 1 on 16. Addition will give us this. So it will give us 2 times cosine of 4 theta minus 4 times cosine of 2 theta plus 6. And we are done. Yes. I think that is the answer that I have. That's the answer that I have. Look, this one have 2 here. So it will be 8. Yes, this one is 2 cosine of n theta. So if we have 4, it will be 4 times 2 cosine of n is 2, so 2 theta. So if you multiply by 2, we are going to get 8. That is right. If you like, we can multiply 2 by 6, or we can factorize 2 out. So if we factorize 2 out, we get 2 out of 16 cosine of 4 theta minus 4 cosine of 2 theta plus 3. And this will be 1 out of 8 cosine of 4 theta minus 4 cosine of 2 theta plus 3. Please, these don't touch them. They are angles. We can't factorize them out. Now let's take a cosine to the power 3. And then I think that will be all. If we take cosine to the power 3 of theta, we are going to get 2 times cosine of theta to the power 3. Yeah, this added to the power 4. Okay, to the power 4. Have I done to the power 3? Yeah, I think I've done to the power 3. So let me do to the power 4. To the power 4 is equal to z plus 1 on z to the power 4. And this will give us 16 cosine to the power 4 of theta equal to, we expand this one, so we have z to the power 4 plus 1464 4z to the power 3 times 1 on z plus 6z squared times 1 on z squared plus 4z times 1 on z to the power 3 plus 1 on z to the power 4. That will give us z to the power 4 plus 4z squared plus 6 plus 4 on z squared plus 1 on z to the power 4. So we are going to take a cosine of 4 to the power theta. Sorry, cosine of theta to the power 4 is equal to 1 out of 16 times the whole of this. And this one is now easy. So you have 1 out of 16 z to the power 4 plus 1 out of z to the power 4 plus 4 out z to the power 2 plus 1 out of z to the power 2 plus 6. This will be 1 out of 16. This one is what we have here. 2 cosine of 4 theta plus 4 into bracket 2 cosine of 2 theta plus 6. 1 out of 16 to 2 cosine of 4 theta plus 8 cosine of 2 theta plus 6. And you can multiply 2 by 1 out of 16, or we can factorize 2 out as I did when I was doing the cosine, when I was doing the sum. So this will give us 1 out of 8 cosine of 4 theta plus 4 cosine of 2. That's our final answer. I love you. Yeah, let me do this one. I have this one here. Will I write that one down? No. Oh, I was having one of them here. Let me look for it and do it. I think to the power 6. Yes. Let me do sine to the power 6. Let me do sine to the power 6. I have it there. Let me do it. Let's do that one. Let me do sine to the power 6. So we are looking at, I said sine to the power 6 of theta. So that one we go for this one. So we are going to have 2i sine of theta equal to z minus 1 on z. So we take power 6, take power 6. And this one, we are going to have 2 to the power 6, that is 64. Then sine to the power 6 of theta. Then what is I to the power 6? This is I squared dot I squared dot I squared. That is negative 1 times negative 1 times negative 1. That is negative 1. So we bring negative here. Equal to, here let's use the Pascal triangle. So we continue. This is 1, 2, power 1, power 2, power 3, power 4. Sorry, power 0, power 1, power 2, power 3, power 4. So continue to power 6. But I think I have it here. I did the expansion here. Oh wow. I did the expansion here, so let's remove that one. Oh, yeah, I have it here. I did the expansion here, I have it here. So let's use that one. So here we are going to have z to the power 6 plus 6 times z to the power 5 minus 1 on z plus 15 times z to the power 4 minus 1 on z squared plus 20 times z to the power 3 minus 1 on z to the power 3 plus 15 times z to the power 2 minus 1 on z to the power 4 plus 6 times z times minus 1 on z to the power 5 plus minus 1 on z to the power 6. So this one will give us sine of theta to the power 6 equal to minus 1 on 64 times z to the power 6 minus 6z to the power 4. Negative times positive is negative. Z will cancel this and you have z to the power 4. This will give us z to the power 4 times 1 on positive z, 1 on z to the power 2. And this will give us plus 15z squared. I hope you get that. This will cancel this z squared times 15. And this will give us z cube times 1 on z cube. And we will get negative. So this will give us negative 20 plus, or this will give us positive. So it will be positive 1 on z to the power 4 times z squared. This will cancel this and we have 1 on z squared times 15. That is 15 on z squared. Wow. Minus, because positive terms, this is odd power, so it will definitely give us minus. So 6, then you have z times 1 on z to the power 5. So here, this will cancel this, we have z to the power 4 as the denominator. Then this will be positive 1 on z to the power 6. Now you have minus 1 on 64 times z to the power 6 plus positive 1 on z to the power 6. You are just collecting the ones with the same z power. This is to the power 4. This one you have to the power 4. So you have minus 6 z to the power 4 minus 6 on z to the power 4 plus 15 z squared plus 15 on z squared minus 20. So we have minus 1 on 64 z to the power 6 plus 1 on z to the power 6 minus 6 into bracket z to the power 4 plus 1 on z to the power 4 plus 15 into bracket z squared plus 1 on z squared minus 20. And this will give minus 1 on 64 times, this will give us 2 times cosine of 6 theta minus 6 into bracket 2 times cosine of 2 theta. That's what we have there. Sorry, that's what we have there. Z to the power n plus 1 over z to the power n. You are getting that, huh? Plus 15 into 2 times cosine of 2 theta minus 20. So this will give us minus 1 out of 64 times 2 times cosine of 6 theta minus 12 times cosine of 2 theta plus 30 times cosine of 2 theta minus 20. So here we can factorize negative 2. We can factorize 2 out. Or we can factorize negative 2 out so that it will come and cancel the negative in front. So let's do that. If we factorize minus 2 out, we're going to have minus 1 on 64 times minus 2. And since we are factorizing negative 2 out, look at this. If this is negative, it will be positive. If this is positive, it will be negative. If this is negative, it will be positive. If this is positive, it will be negative. So let's start. I'm going to have minus cosine 6 theta, right? Plus 6 cosine 2 theta minus 15. Oh wow, here is 4, not 2. 4, because you have n to be 4, right? Cosine 2 theta, and this will be plus 10. So we are going to have positive 1 out of 32 into, we can group the, is it necessary grouping? We can bring the 10 in front, the positive ones in front. So we have 10 minus cosine of 6 theta plus 6 cosine of 4 theta minus 15 cosine of 2 theta. Yes. Let me check the answer I have here. Did I do that one? Oh, I didn't do it. Yes, I did it. It's here. Let me check it from here. Wow, that's what we have. We have minus 15 cosine of 2 theta. Yes. We have minus cosine of 6 theta. And we have plus 6 cosine of 4 theta. Okay. So that is that. Oh. If you really want to rearrange it again, you can do so. Thank you for watching. Please like, share, and subscribe to my channel. Please remember to leave your comments. Bye bye.